Live, let me go to the website. So today on the schedule is polymorphism example, which probably should be plural. We're going to do live coding all today, and today is, just like any of my live coding days, fairly open-ended. We're going to go into the code, and if we get sidetracked, we get sidetracked. We're just going to talk about ideally whatever you all want to talk about. But if nobody has suggestions, I got more than 50 minutes of stuff in my head that I want to show, so I'll just by default go down that stuff. But that's what we're going to do, just spend the day in the code. As opposed to days where I'm on slides, like when we're in slides, like I'm on a rail. Like those slides are guiding me. That's what we're going to do, is go slide to slide to slide. When I'm live coding in the code, I'm fine going wherever we want to go. So if you have questions during it, if there's something you want to see, even if it's not related to polymorphism, in the last lecture, I did quite a bit of stuff that had nothing to do with polymorphism, just general like coding tips and tricks, and just dumping some cool information out of my brain into the lecture. So we can absolutely do that. All the content for polymorphism has been covered with these two lectures, Monday and Wednesday. You have everything you need for interview, quiz, task, and task 8. So there's nothing we have to cover today. Today is just all about showing examples to help you more understand polymorphism. And if you're all good on polymorphism and you want to see other things, we'll talk about other things as well. So if you have any questions, hit me up in the chat or raise your hand, and I'll be happy to show whatever you would like to see. So before we get into code and just do some live coding, I'll open the floor if anybody wants to ask, or the inverse square root they were talking about in the last lecture. That's a wild thing. If anybody has anything they want to talk about before we get started, and while we get started, like I just said, it's open-ended. You can just interject whenever you want. And we're kind of at that point of the semester. This is the worst part of the semester, in my opinion. We're at that point of the semester where we're all exhausted. I'm definitely feeling it. I assume most, if not all of you all are feeling it. That it's a rough part of the semester. We've been doing this for long enough, 9 weeks now, that we're exhausted, but the end isn't quite close enough to be excited that it's almost over. It's that lull part of the semester. So I'm fine if y'all just want to bullshit or something. If you want to talk about pretty much anything like Quake magic numbers, ideally related to computer science, but even if it's not, I'm open to being sidetracked today. But if not, I'm just by default going to go through the week 6 code. So we have the week 6 code as a starting point. This is when we were talking about inheritance, and we used classes for everything. Last lecture, we did start this a little bit in this lecture. We have an abstract class for game item, but we're going to further this and morph the week 6 code into the week 9 code, apply polymorphism and abstract classes, abstract methods, and interfaces to all of this code that we saw before. Because in the slides on Monday and Wednesday, I said, like, here's what an interface and an abstract class are, and then, bam, here's what the week 6 code looks like with the abstract classes and interfaces. So I want to fill in that transition of how we got from point A to point B. That's what, by default, what I'll do today. Unless there are questions about anything. So we made game item. What are the application objectives this week after task 9? Ooh, I'll be happy to talk about that. So the application objectives, I'll be honest, they're not 100% designed yet. Especially AO1, I have ideas and still at that pre-idea kind of design phase of what this one's going to be. But the big part of it will be testing with mocks. This will be the biggest idea that we want to do. So with this, the question is, we have tests. So far we've written unit tests where you have a method with some pretty clear input-output behavior. On these inputs, this method returns these outputs. And sometimes you have testing on objects where the state of the object, whatever values it has in its instance variables, can affect that behavior. So it's not strictly input-output. It's input-output that depends on the state of the object. When we get into mocks, that's where we have code that we're testing, which depends on multiple for lack of a better term, I usually call them modules, but two pieces of code are interacting with each other, and some of that code might be really complex. So the intent right now, what AO1 might be, as long as I can make the logistics not too painful, is you have a database that's running and storing your information, and you have a method that you want to test that talks to that database. How do we test something like that? Well, you spin up your database, you run your database, you connect to it, you have your connection credentials, your username and password, your URL and everything, you connect to that database, and then you call your method, have it talk to the database, and then test your methods like that, which is a pain, which is something we rarely ever actually do. So when we're testing that code, what we do is mock out the database. So we don't have to have a whole module on databases like we did in 1.15. We mock that out by replacing it with dummy code that takes the place of the database without actually having to run a database server or anything. So you can actually test that method. So testing with mocks would be the big thing. You have one big complex thing that your code depends on, and you replace that with a mock, just a simulation of that thing, and then test your code. Turning that into an actual assignment, it's the early stages still. Application objective 2, this is going to be all about the state pattern. This one, I've done state pattern assignments a ton, so I got tons of ideas. I think I'm going to use microwave for this one. You're going to write code for a microwave. Either microwave or calculator, I don't know which one yet. That's something with a bunch of buttons that you press, most likely, where you have to code the implementation for that. I'll use calculator for this example. I don't know what it's going to be by the time it's released. But a 4-function calculator, addition, subtraction, multiplication, division, and then your 10 digits and possibly a decimal button and an equals button, and then in a clear button to round it out. And then implement that functionality of when the buttons are pressed, your methods are called whenever a button is pressed, and then you have to get the right thing displayed when like equals is pressed, for example. Without using any conditionals. No if statements, no if else, no switch, no try catch. No code can be ran conditionally. Now, coding the calculator itself, that's like a 1.15 assignment. You could do that. Doing it without conditionals is going to require the state pattern, which is a way to change the behavior of our code depending on the type of an object using polymorphism, instead of changing what the behavior of your code depending on the value of an object, which is a conditional. If some Boolean expression that depends on the current state of memory, then do this, else do this. Instead, we're going to have that same behavior, but through polymorphism, which is, I think, a really fun topic. It is an application of polymorphism, so it used to be part of the main content of 1.16, but it makes more sense for it to be an application objective-only thing, because it's an extension of polymorphism. But this leverages polymorphism to be able to get that job done. And then data structures, the intent is to do a big weighted graph thing, and then these other two lectures, I don't think we're 100% settled on what we want to talk about with data structures. I kind of want to do depth first search here. I don't know what we're going to end up doing. It might depend on how much energy Paul and I have by that time. And then merge sort, we'll talk about merge sort and recursion. Maybe I'll talk about merge sort for two days. But weighted graphs is the part that the homework assignment AO3 is going to be about. So we haven't really talked about graphs yet, so it's hard to talk about weighted graphs. But with weighted graphs, we'll have graphs where each edge has a weight to it instead of just an edge existing. And our example will be airports connected by flights, and each flight has like a time for the flight and like the duration of the flight, the cost of the flight. There'll be certain costs associated with those edges or certain weights. And we'll be at review week. Can we use ROs for those? No. So you can't use ROs on anything related to any application objective. That's pretty blanket across the whole course. It is applied to the entire course. For example, that's why you can't get the AO on a quiz if you used an RO to take that quiz. You can't get well, of course, the expected deadlines you can't get. But no, you can't use ROs on the AO objectives. Though these are just straight up deadlines. Deadline, 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 no expected deadlines. Rate tests 1 through 9 LO, including AO 1 through 3. I assume you mean by difficulty? I can do that. I'm happy to do that. When can we make video games? Right now. There are libraries, like legit right now. There are libraries, if you Google, I'll rank the objectives. If you mean by difficulty, if you can follow up and say if you mean by difficulty. Or I can rate them by how fun I think they are, I guess. Java, game, dev, bless you. What just game engine? Unity isn't really Java. List of game engines. I'm blanking on the popular one. I think it's Play. Open source 2D games, if you want to build 2D games. But the idea is you would go find a library. Let's try to do this, actually. I think we can do this fast enough to fit in a lecture and still do some polymorphism stuff. Yeah, the AOs are going to be harder than I won't say the AOs will be harder than task 4. Probably like more difficult than task 4. Task 4 was hard for different reasons, though. Task 4 wasn't hard because it was hard. Like task 4, what you were actually asked to do, I still maintain. I'll say this forever. Like what you were actually asked to do wasn't hard. It was understanding what the hell I was trying to ask you to do that was hard. So 4 kind of fell apart for different reasons. But once you actually, if you look back at your code for task 4, like you weren't doing anything crazy. You were generating inputs for test cases and then writing some tests for like sorting. Like you've known how to sort since kindergarten. Sorting songs by title. Like once you actually got to the point where you're sitting down and writing your test cases and you understood the structure that we were asking for, not all that hard. I don't think anyway. Understanding what Bayesian rating is, that's kind of tough. But once you actually sit down to write the code for Bayesian rating, for tests especially, writing tests for Bayesian rating, like it's straight up math. And then you had to remember your edge cases. What happens if a song has no ratings? What happens if I have 0 for the Bayesian average number of extra ratings? Things like that. But the actual code you wrote wasn't that difficult. So that's an assignment that has to be revised in future semesters to get rid of that. That's what I call artificial difficulty. We got to get rid of the artificial difficulty. A lot of task 4 frustration wasn't, man, I'm having trouble understanding the concepts of this course. That's not what made task 4 hard. It was artificial difficulty. The application objective tasks will just be, assuming I design them well, taking the lessons from task 4. It'll just be difficult to understand what to code and get that code down there. But it shouldn't have the artificial difficulty. So the idea, this isn't going to be what I want. I think it's a play framework. But the idea is, since I started this rabbit hole, let's do play framework. No, play is a web framework. Damn it. Java game framework. I'm looking for one that I've heard of before, so I know that it's something that is legit. What's the best game engine framework for Java games? Not available. Find one that. Do this one. I had this whole thing in the last lecture. I went on a tangent where I said, don't just copy and paste code make sure you understand it, and then type it in your own, in your own words. We ain't got time for that right now. So let me just copy and paste this. Let's try to build a quick game. So the idea is you'll find a library. You're not going to build a game from scratch, unless you're crazy. I don't know. I've done that before. It's fun if you're crazy like me. But you're usually not going to build a game from scratch. What you'll do is find a library, a game library, and have that library do most of the heavy lifting for you. And then go through tutorials, read documentation, figure out how to use that library with your Java skills, your programming skills, and then make that, have that library, build a game with that library. So I grabbed one here, this LWJGL, and I get all kinds of errors, of course. I shouldn't say of course, we haven't really talked about this ever. Because I need to download the library. This library doesn't exist in Java itself. It's code that some team of people wrote and then released to the world and said, here, you can use our code. But it's not included in Java. We have to get their code for the game engine itself. So we want to figure out how to get this code into our project. I'm looking for Maven here. Of course, it took me to the top-level Maven. This is not what I want. I mean, I guess that's what I'll have to do. What's the name of this library? LWJ, I'm not going to remember that. Copy. And we're using Maven for our projects. I haven't talked about that much this semester. I used to talk about it a lot more, but IntelliJ's gotten really good at automating all this and just doing it all for us. But what we do is go to Maven. I don't know what this site is. We want to go to Maven Central. And then search for the library that we're looking for. Yeah, this is a making video game speedrun. We're at least getting this demo working. Why am I on Google? What the? Maven Central. This is what I want. I just want Maven Central. And I'm going to paste the library I'm looking for and find the library that I want. Are those the ones I want? LWJGL. LWJGL. Well, let's try this one. And then when we find the library we're looking for, we're going to pick the version. I'm just going to pick the latest one here. Go to Maven and grab all of this. This website automatically copies it because it knows exactly what we're doing. It knows we're just grabbing this library. And then I want to go to my pom.xml and add this as a dependency. So we have one dependency we've been using all semester, JUnit, that we're using for our unit testing. That doesn't come with Java. I'd argue that it should at this point. It's pretty ubiquitous. But we're going to paste our dependency here so we can download this with Maven to get it linked to our project. And then sometimes it'll happen automatically. This time it didn't. I'm going to go to Maven in the sidebar and refresh. And it should grab that dependency and install it into my project. And then once that happens, hopefully it works well here. Errors went away. And then we have that library. We just installed that entire library, probably hundreds of thousands, if not millions of lines of code, just dumped into our project, ready for us to use. And I'll go back to that game example. All our errors go away, except one, apparently. Hello world, because I changed the name of the thing. Let's run this thing and see if we get a game. Oh, no, don't do it for him. Do me. We're getting there. I'm determined now, though. Illegal state exception may only be used in the main thread. That thread, first name of the process. Oh. Ooh. What is this? No, I don't want to get deep into that. Okay, we can do this though. We're just going to have to change our configuration. I guess we're really getting sidetracked today, and that's perfectly fine. So I'm going to change my run configuration. Do they call it environment variables? Or am I too far zoomed in? I'm too far zoomed in, I think, to see the rest of this. Oh, never mind, right here. Program arguments. So I'm going to add that program argument, which is something we need quite a bit of time to talk about. These are on JVM. I did that. I already did that. Oh, no. X start on first thread. And run. Main thread, and that thread must be the first thread in the process. But it is the first thread in the process. Why are you complaining about this? Is there an apply button? When I go back into configurations, it's still there, and the apply is grayed out. Start on first. I'm cutting and pasting this, right? That's what I'm doing. Thread. Okay. All right. Let's try this again. So this is a configuration of Boolean. I'm not sure how it wants me to change that. Okay, so we want to change this thing. Configuration dot new configuration dot state init dot boolean. Can I just change this to false? Bless you. Why? Why would it tell me to do that if it's... So this is a private constructor. Or not even private, it's package default. So it's not letting me call the constructor because it's not public. So why is it telling me to mess around with that? Okay, all right. We can do this. Configuration does have set. We're going down too much of a rabbit hole here, but I'm a little too stubborn to give up. Null. Oh, come on. And it's final anyway. Oh, so I can't even change it anyway because it's final. All right, so set. Oh, there's a set method that takes a Boolean. Okay, cool. I mean, it's running. Is that a win? Yeah, I'm waiting for a GUI to pop up. Where's my GUI? Don't tell me I went with a text-based game engine. There's no way. Yeah, no, it's talking about Windows and stuff. Nothing popped up. Come on. Thought we were there. when it runs. What more do they want from me? What do I have to do to get a window popping up? I'm doing it this way. Okay, I have no idea what this is. We're going to go to Git, which is something you can do, by the way. There's all kinds of open source code out there, which means the code's just out there for you to use. I went to GitHub, just found a repo with something. I don't know what it is. We're going to go to Git clone, just like we clone the starter code for the project or the examples repo in the course. I'm going to paste that URL I grabbed, and we're going to get a new project popped up with somebody's code. It'll be something. And hopefully it'll run out of the box. Maven's doing its thing. So they have a pom.xml with probably tons of dependencies. Maven's going to do its thing. Hopefully it doesn't take too long. These errors will slowly go away. The short answer is yes, you can build video games with what you know right now. With a bit of reading documentation online and going through pain like this, but you have the skills, you have the ability. Source, let's look for some main method. Game, sounds good. Voxel game, ooh, maybe we'll get Minecraft. All right, show me something. Don't tell me this is all a waste. Piss off. Hopefully it's the same error, though. We already debugged. Okay, so it is the same thing, it looks like. What's that? Can only be used on the main thread. No, it's the same one. Looks like. I mean, I didn't read the whole thing, but. And it's convention that the main method, these are things that we've talked about throughout the semester on and off. But here you can really see why. We have a 3,500 line file. It's common convention that the main method is the last thing in a file. So it's easy for me to find the main method. I'm just going to scroll all the way down to the bottom of it. I'm going to paste our hotfix for that. And hopefully we actually get a GUI popping up here. But if you could put the main method, if people put their main method just wherever, it'd be forever to find that thing. I'm wondering if this is showing up on a different desktop. No, because it's not showing up in the tray either. Not showing up. Damn, man. I mean, it's running. There's a game running on my machine right now. And I can hear my fan burning up. My Mac is definitely trying to do graphics. But we might have to call it at this point. Unless we build. We build the whole thing. This should be set up. This pom.xml, I would assume, is set up to. That's not good. Why is this hard-coded to Linux? Oh, never mind. It should be set up to output in an executable jar. I would guess. So if we build the project, we'll get something in. Something generated for us. It's built. Well, we're going to have to call this one. It ran. I'm taking that as a partial win. They're all going to have the same error. But it's just not showing us any GUI. I wanted a GUI to pop up. That's all I wanted. Oh, I can't make this any bigger. Oh, I have a bunch of Java running. I'm never going to know which one is the one we're looking for. JSF helper. And there definitely is a task running. I just don't have access to it. Like, it's not popping up a GUI anywhere. All right, well, I got a call. Let's get back to polymorphism. Man, that would have been a cool moment if something popped up there. We'll get them next time. Yeah, that would be fun enough. Maybe I'll work on that and get something to show. Maybe we'll take like the first 10 minutes of next lecture and just show something running. Maybe it'll run just magically this time. Dumb. All right, well, let's talk about game items and health potions. We'll run our game. That's cool too, right? So last time we changed the game item class to abstract. Yeah, we cannot make video games, apparently. Should I give it one more chance? Let's just do GitHub Java game. Maybe it's that library that's not playing nice. Battleships. This looks fun. Has a POM. Assets. Rebuilds. We want to do it from source. If we just download and install a game, that's not fun. Y'all can do that. Let's just go for it. Play some Battleship. I found the Maven file. Ooh. There's a lot going on. This is made to be... Might be a bit much. This is a bit more complex than I'm going to be able to wrap my head around in a couple days. Yeah, I don't want something with client and server. That first one was made to be a server as well. Snake, this should be simple enough. Okay, this might be a little too simple, but we're going to get a game in the next 15 minutes, even if it's just Snake. This looks like it's not even using a library. This looks like it's using just raw Java, which I don't even remember what does Java have built in for a graphics library? It might be AWT. Oh my goodness. This This is impossible. Project files. Telling me, why can't I? Okay, we're getting close, I think. Hey, there we go. Spacebar to start game. Oh yeah, we're gaming. It's just Snake, but we got there. I'm getting the high score now. This might actually take a while to get the high score. Yeah, this is going to take a while. So here, I'll turn this into a lesson at least. So what we did was grab somebody had public code. They made it available online for us to grab. I'm sure there's a license attached to this. Of course, there's not going to be. There should be a license somewhere, maybe on each thing. But we can look through this code and start modifying things. What I want to do is crank up the speed of this game. Oh, easy, normal, hard. Maybe that's those three things that actually, no, let me just run it again. I think those are those three buttons at the beginning. I think that's supposed to say easy, medium, and hard. Let's try to make it hard. Oh, yeah, there we go. Never mind. They already have the feature. Okay, now, oh. How do I restart? I guess I don't. It doesn't have a restart feature. Oh, that's, I call BS on that one. You can turn around. So if I'm going in one direction, and oh no, I didn't. Well, what did I do then? But I just backed up into myself. Maybe I did a whole circle. I just hit the buttons too fast. Oh my goodness. I'm bad at this. All right, but we got there. I've called that a win. Even though it was just Snake with no external libraries, this is just raw, which might even be better, just to show you that you can do this stuff right now. This is using AWT, I believe. Where's my imports? Yeah, Java. This is included in Java Swing, which I can't stand, but it does work, and it's built into Java. You can just import these classes into your code right now, anywhere, and it'll work. When I use GUIs, and if I build a GUI for like calculator or microwave, like I was mentioning, that'll be Java 2D, and we'll build it right from scratch. So this is from scratch without a library, without a game engine, and then you're responsible for building your own game engine. If you want to build simpler games, this is a way that you can do that. All right, and did I ever get an answer on rating the tasks? I mean, AI violation speedrun. Yeah, if I submitted this for homework assignment, for sure, AI violation. What is my favorite video game? Oh man, that's a tough one. I'm a fan of the Final Fantasy series myself. It might be my favorite. don't think there was ever response on rating the things. But I think in terms of raw difficulty, like 9 and the AOs are going to be like the toughest tasks. Again, task 4 was artificial difficulty in my mind. Okay. Let's at least get to some of this stuff. We covered everything we needed in Monday and Wednesday's lecture, so this was just reinforcement lecture. So let's get some of that reinforcement at least to see the path of how we get from point A to point B. So we made game item abstract. And we made this use method abstract. Actually, I want to make this one abstract so I can make the same point I made in the other lecture. So when a method is abstract, it cannot have a definition. So this error is going to say, hey, you told me this is abstract, but you gave it a definition, which is equivalent to giving it a body. So when you declare a method, you're just giving it the signature, which is everything before the body. And then you can't give it a body or a definition if it's abstract. We just cap that off with a semicolon. This other method is not abstract. So this we're going to have to give some default behavior. So these two methods are very different. There's quite a bit of, there's a nuance here. But this is a big difference between these two methods. The second one, the use that takes a player, has a definition, and that definition is does nothing. The first one doesn't have a definition at all, so what it does is undefined. We don't know what it does. It just doesn't have any definition. So an empty body is very different than a body that doesn't even exist. And then we can't create instances of equals, if I can type, oh man, new game item. So we can't create instances of our abstract types, because if we did, say we were allowed to do this and we said item.use and called this method has no definition. As opposed to having a definition that does nothing, it has no definition, it's undefined. So what's going to happen when we call the use method? We don't know. So Java says, you know what, you can't even get yourself in this situation where you're trying to call this method, so we're not even going to let you instantiate a class that has any abstract methods. So I was hoping the error would pop up. It's abstract, can't be instantiated. Can't create new objects of an abstract type. And the same applies for interfaces. So we took this a step further. We got rid of this method and threw this in an interface. And when you create a new class, you have this choice. You can choose what type it's going to be. And I can choose interface here, and it'll set it up as an interface. But let me do usable as a class. And let's say you forgot to click the interface button. No big deal. The only thing that button does for you is puts interface here instead of class. So if I do this, interface, now I have the same thing that would have happened if I clicked interface in that dropdown. So I have an interface usable. I'm going to have the use method. Oh, I got to talk about variables today. I made that mistake in the middle of the lecture last time. So we have this use method that's going to return void. And I don't have to have anything else here. If I do public, it's going to gray it out and say this is redundant because every method in an interface has to be public. Same with abstract. Every method has to be abstract, so that's redundant. And likewise, just because it's in the lecture question, I better mention this. I can't do new usable because it has the same issue. It has undefined behavior. The use method that takes a player, we don't know what it does. We can't create an interface. Not allowed. Abstract classes and interface, you can't say new and then create instances of those things. Not allowed. And then in the last lecture, I said I'd revisit this. I said, you can't put instance variables in an interface. And then I typed int x equals 7 or whatever, and it didn't give me any errors. And I panicked and freaked out and had to figure out what the hell was going on with this. You cannot create instance variables in an interface, but this looks exactly like an instance variable. And I'm like, what is going on here? So if I do the same thing like I did down here and start adding things to this, public, static, final, That's all of them, right? Const. No, wrong language. Final. No, I already have final. Public, static, final. They're all grayed out. They all say the same thing. Most importantly, this static here, it's redundant for interfaces. So if you create a variable in an interface, it's automatically public, static, and final. So public, meaning it can be accessed from anywhere, of course. Static, meaning that it is a class-level variable, not an instance variable. So we haven't talked about static versus non-static in a while. Non-static means those variables and methods. We've only seen it with methods. Those variables and methods are part of objects of that type. They belong to the objects, the instances of that type. If it's static, we've only seen static methods. We haven't seen static variables except when we briefly went into the math class. Static variables are variables attached to the class. So if I want to access this variable x, I type the name of the class to be able to access it. I can't access that variable through instances of the class, aside from the fact that I can just always access it because it's public and it's a class variable. So from anywhere in my code, I can import usable and access this variable x. And finally, final means that I can't change. I can't change the value. I can't reassign x. So it has to be public, static, and final. And if you don't include any of those keywords, it is still public, static, and final. I can still access it through the class, and I still can't reassign it. So it looks like an instance variable. Kind of bugs me that Java does this. Java